Hello students, hope you are doing well. In this video we are going to look into the next topics in gravitation. The topics that we are going to look into in this video are orbital velocity and escape velocity. So let's try to understand what is orbital velocity. The speed with which a satellite moves in its orbit is known as orbital velocity. So orbital velocity is what? It is the speed with which a satellite moves in its orbit around Earth. Now it need not be always a satellite. It can be a natural or let's say an artificial satellite. Now if you look at this, what are the forces acting on the satellite? The centripetal force is acting towards the center, centripetal force is acting towards it, and centrifugal force would be acting away. Now we know centrifugal force is always given by mv square by r. So I can say mv square by r equal to gm. I'm taking small m to be the mass of satellite into me. Instead of small capital R, I'll take r, where r is the radius of the orbit. Like if this is the radius, r is the radius of the orbit. Gm me by r square. So I'll cancel 1r, I'll cancel m. So what am I left with? I'm left with v square equal to gme by r, or v would be equal to root of gme by r. Now that means what all factors that orbital velocity depends on? Orbital velocity depends on mass of the earth or mass of the planet around which a satellite is revolving, and the radius of the orbit. Now the things on which orbital velocity does not depend is, it does not depend on radius of the planet, it does not depend on mass of the satellite. So it does not depend on radius of the planet or mass of the satellite. It only depends on mass of the planet around which it is revolving, and the radius of the orbit. Now when the orbit is very close, which is practically impossible, but if I take theoretically that the orbit is very close to the surface of Earth, in that case r equal to r. In that case orbital velocity is root gme by r, right? So this is what is orbital velocity if the orbit is almost along the surface of the planet. So this is about orbital velocity. Now we'll use the concept of orbital velocity to find the total energy of a satellite. Now total energy, total mechanical energy of the satellite would be sum of kinetic energy and potential energy. Kinetic energy of satellite would be given by half mv square, where v is orbital velocity. So that is equal to half m. V is root gm by r, so v square would be root gm by r whole square. So that is equal to half m into gme by r, or I'll write it as gmem by 2r. This is what is kinetic energy of a satellite, where r is the radius of the orbit. Now let's look at potential energy. Potential energy is minus gmem by r. This is potential energy. Then what is total energy? Total energy would be potential energy plus kinetic energy. So that is equal to minus gmem by r, small r, where r is the radius of the orbit, plus gmem by 2r. So that is equal to minus gmem by 2r. This is what is the total energy of the satellite. Now let's look at the variation of energy as satellite moves from inner orbit to outer orbit. As the satellite moves from inner orbit to an outer orbit, what will happen? R increases, and kinetic energy, because r is in the denominator, kinetic energy would decrease. So I'll write kinetic energy would decrease. Now look at potential energy. As r increases, the magnitude would decrease because there is a negative sign, and the value would increase. So potential energy would increase. And total energy, again in total energy also we have a negative sign, so total energy would increase. So if a satellite is moving from an inner orbit to outer orbit, its kinetic energy decreases, potential energy increases, and total energy increases. And if you want to find a relation between kinetic energy, potential energy, and total energy, we can see that kinetic energy is equal to half the magnitude of potential energy, and is also equal to magnitude of total energy. So that means if you know one value, you can find the other values by using these relations. You don't have to go back to the whole formulae. So in this way, one of the biggest confusion that students encounter is how does the energy change. So keep in mind the negative signs, and if r increases, the value increases, even though it is in denominator, that's because of negative sign. So if it is a positive value, if R increases, the value decreases. And that is the reason why kinetic energy decreases, potential energy increases, and total energy increases. Hope that is clear to you. Now let's move on to the next part, that is escape velocity. Escape velocity is the minimum speed with which, if an object is projected from the surface of Earth, it would escape the gravitational field of Earth. So I'll use the conservation of energy principle to derive an expression for escape velocity. Now at the surface of Earth, let's say I give a velocity equal to escape velocity to the planet. Then the kinetic energy would be equal to, I can write half m into v square. M is the mass of the object which is imparted a velocity equal to escape velocity. And potential energy we all know on the surface of Earth is minus gmem by r or re. Now let's say when it just escapes the gravitational field of Earth, I'll say it is infinity because there is no effective field. Now because it is just escaping, its velocity is 0. And what is potential energy? When it just escapes, there is no more gravitational force coming into picture. So potential energy is also 0. So what is total energy at infinity? I can say total energy at infinity equal to 0. So here let's see what is total energy. Total energy would be equal to half mve square minus gmem by r. Now this should also be equal to 0. Now why this should be 0? Because gravitational force is conservative force and the total energy is conserved. Total energy at every point should be constant. So taking this into consideration, I can cancel m and m. I'll be left with ve square by 2 equal to gme by re. Or ve would be equal to how much? Root 2 gme by re. Right, this is escape speed or the minimum speed at which an object projected from the surface of a planet would escape the gravitational field of planet. If I put the values to be mass of Earth and radius of Earth, I get this to be approximately equal to 11.2 km per second. Now the same procedure can be done for any point. You find the total energy there, equate it to 0. Whatever the value of ve is, v you're getting, that would be the escape velocity from that particular point. It can be from the surface of a planet, it can be from a height of the planet or whatever. Now sometimes we see situations where we compare escape velocity with orbital velocity. Again, be very careful in comparison because orbital velocity we have radius r as the radius of the orbit. So if the radius of the orbit is very small, that is almost equal to the radius of Earth, then we have orbital velocity equal to root gme by re. So from this I get escape velocity equal to root 2 times orbital velocity. So again, as I told you, this is valid only when the orbit is very small, which is practically impossible. So after that, let's look at other thing. In which direction should an object be projected for the body to escape? Let's say one object is projected like this, one is projected like this, one is projected like this. I'll name them. Let's say this is 1, this is 2, this is 3. All of them are given escape velocity, then which would escape? Now, if all of them are given escape velocity, all of them would escape. Only thing is, the one which is projected perpendicular to the surface would escape sooner than the other, because escape velocity does not depend on the direction in which the object is projected, right? Of course, the time that an object spends in the gravitational field would depend on the direction, because the rate of change in velocity might be greater or less, because acceleration due to gravity is always perpendicular to the Earth's surface. So the object which is moving perpendicularly will have maximum effect of acceleration due to gravity, and hence it would slow down faster than the others. And hence that is the reason it would escape the gravitational field faster. So one more important thing on which we have been getting questions is that escape velocity does not depend on the direction of the projection. If you give escape velocity at any angle, it would definitely escape the gravitational field of Earth. Now, other questions that we get is, if an object is given twice the escape velocity, what will be the velocity when it goes into interstellar, or when it crosses the gravitational field of Earth? Again, use the total energy. If you are giving twice, instead of v square, put it as 2v square and substitute it and solve it. Whatever energy is left, that becomes the kinetic energy, because there is no potential energy at infinity. So solve that, you will get the remaining kinetic energy would be the energy that is left with the object. And after that, because there is no force, whatever velocity with which it is entering into the interstellar, it will continue to have that velocity. So That's so they don't use any equations of force, use equation of conservation of energy. So that is what is there in orbital velocity and escape velocity. Let's have a quick review of what all things we have seen. We have seen what is orbital velocity. Orbital velocity is the velocity at which a satellite moves around a planet, and we have seen that orbital velocity depends only on mass of the planet and the radius of orbit. It doesn't depend on mass of satellite. Then or the radius of the planet. Then we have seen escape velocity. Escape velocity is the minimum speed with which an object should be projected from the surface of a planet so that it escapes the gravitational field of the planet. And we have seen that this also depends only on mass of the planet and radius of the planet. It doesn't depend on anything else. It doesn't depend even on the mass which is projected. Fine. So hope you could follow this. Thank you very much for watching this video, and keep watching other videos of concepts as well as questions that are made for you on Get My Class. Thank you very much.